In examples 7 and 8, we're looking at dimensional change. Um, with regards to surface area, this idea is pretty similar to something that we talked about in chapter 9. Area is just like surface area. They're both two-dimensional measures. I mean, they're measuring the exact same thing. Don't be confused that surface area occurs on three-dimensional objects. The measurement of area itself is a two-dimensional measure. So in example 7, we're told that the edge length of this cube is tripled, and we are asked to describe the effect on the surface area. We don't need to find the new or original surface area. Sometimes that's helpful to look at, though, and maybe we'll do that on this problem just to look at the difference. So as we have right now, a cube with an edge length of 8. The original surface area for a cube, we could find the area of a single surface, which in this case would be 8 squared, and we'll multiply it by 6 because there are 6 faces on a cube. So we know that 8 squared is 64. 6 times that 64 gives us 384 square centimeters. Now, the edge length is tripled. So we're multiplying by 3. So now the new edge length would be 8 times 3, or 24. So the full surface area of the new cube follows the same process, except now it's 24 that's being squared. So 24 squared is 576. We're multiplying that by 6 for the 6 faces on a cube. And we get a new surface area here of 3,456 square centimeters. Now, you can see a big difference here. Let's divide this out to see by what factor this has changed. So 3,456 divided by the original surface area of 384, we get 9. So that surface area has changed by a factor of 9. Well, this makes sense because each edge has been tripled. So if we're looking at a single square surface, what had been 3 is now tripled to 9. This was 3, tripled to 9. So 3 by 3 becomes 9 by 9. Okay, you're squaring both, or you're tripling both of the sides, so that area is now changing by a factor of 3 on this horizontal dimension. It's changing by a factor of 3 on this vertical dimension. So together they're changing by a factor of 3 squared, or 9. Area is a two-dimensional measure, so if you are changing the individual lengths, a one-dimensional measure, okay, for the area to change, you need to change that by a factor squared. Okay, so we showed a lot more work in this problem than we really needed to, because this has we don't need to find the original area, surface area, or the new surface area. We are just concerned that this is multiplied by a factor of 9, the original surface area. So we'll use that knowledge to help us shortcut example 8. We have a cylinder in this problem. The height and the diameter are multiplied by a factor of 1/2. Describe the effect on the surface area. So the surface area in this case is going to be multiplied by a factor, okay, whatever our scale factor is in this case, 1/2 squared. Just like in the previous problem, the surface area is multiplied by a factor of 3 squared, or 9. So 1/2 squared, that's like 1/4. So the surface area is multiplied by a factor of 1/4.